Hello friends, welcome back to my YouTube channels. Today we will be looking at Oracle wait events. So basically in this tutorial I will be guiding you through different Oracle wait events. And before we begin, I will be requesting you to subscribe my YouTube channel Oracle DBA Online Training. On this YouTube channels you will be getting lots of stuffs to learn, such as database architecture, or it could be installation related stuffs, or it could be a data guard related, or an enterprise manager, or there are various tutorials such as latest feature of Oracle 19c versions, and then we have Oracle rack installation configuration. So if you want to learn Oracle database from start to end, you should probably consider subscribing this channel. Okay, so if you want personal training, you can reach me out on these numbers as well as on email ID. So our today's agenda is Oracle wait events. So basically Oracle wait events is something that is come under performance tuning. Mm, so actually I picked up this topic as a random topic. I was thinking about Oracle database related day-to-day activities for any database DBA, and I thought Oracle wait event is one topic that every database administrator should be knowing. So I just planned one video, and on this tutorial, so basically why wait event occur at all. Okay, so we should be knowing detail about wait events. What are the some of the common wait events? We'll look those details in a few minutes of time. So let's start this topic. What is a wait event? So an event that can be defined as a particular function or the task that Oracle kernel performs on behalf of user session or its background processes, and that tasks such as reading, writing data blocks to and from the data files, waiting for latch activation before accessing or manipulating the data in the memory, interprocess posting, communication, and there could be anything. Okay, so I will show you an examples. Okay, so suppose we have one you have one end user. Okay, so you have one end user who wants to perform certain database operation, and he has put some request to a database by logging to the database. And in the backgrounds, this process will be something like this. Suppose he has fired some select query. That select query will be first looked into the SGA if it is available or not, such as it will be looking existing blocks in the buffer cache or the shared pool for your existing SQL IDs. If it is existing, then it will definitely provide the output to the end user. Otherwise, it has to wait for some period of time, and then there will be some operation happens from your SGA, from your data file, like reading the data blocks from the data file to the buffer cache, and then processing these requests to the end user. So there will be some wait happens in between the user request as well as the entire operation to get finished. Okay, so there is a relationship between end user request to your database processing as well as your various operation in the database. So understanding a wait event is a very important task, as every Oracle database administrator should be knowing. So whenever you are facing any performance issues in your databases, or if you're facing any kind of operation is getting delayed in your database, then the first thing that should be coming into your mind should be a wait events. So what is my wait events that is causing this issue, and you should probably try to work on that area. Okay, so in this tutorial we will be discussing some of the common wait events that are there in the database. But before we begin, I will be logging to my database. This is my testing environment. So what I will do, I will be creating one test table, and but before that, I will be creating a snapshot in the database so that I will be having a snapshot reference. So basically, in upcoming days, I will be discussing more about the AWR reports and how to read those AWR reports, and how to generate the AWR reports, how to create a snapshot. So basically, a snapshot is a point of reference, that is like uh, taking a snapshot of your um, database load information, or within a certain period of time, what are the top weight events, or what are the top actions or the events happen in your database. So those information kept into the repository. Okay, so for every 15 minutes or 30 minutes or 1 hour, based upon your retention policies for your AWR, snapshot get created. Snapshot is nothing but a photocopy of your current database information. Okay, so at a particular timing, what is your database is doing, what are the top wait events, what are the top user requests. So those information kept into the repository, those situation is that is called the your snapshot. Okay, so before going into much deeper about wait events, what I will be doing, I will be creating one test table or demo table. Okay, under the test user. So I will be trying to insert certain around 1 million of random data into it, and I will try to see what are the top wait events in my database by executing AWR reports. So that's why I just created one this called snapshot, so that I have a reference point from where I can perform my this operation. Okay, so I have just created one snapshot. Now I will be creating one demo table under my test users, which I previously created on this database. Okay, so now I will be doing one more operation, that is for randomly inserting billions of rows, and so our target is to understand wait events. So basically, I'm just trying to make a relationship between my database and the wait events that we are trying to learn. Okay, so this is my test demo user demo table, and in this table, I'm inserting some around 1 million of different rows from. These are the random values that will be picked up from this loop. There is a for loop that is used to create, that is used to insert the data, and it will randomly pick these values from people array. Okay, people count array, and so we have successfully inserted this, and there is a commit option, so automatically it will be having those data. Okay, so what I will do, I will select count of 0 from this table. So basically, I will be trying to get the total number of data records that is there in that table. So around 1 million rows are already there in these tables. Okay, and now I'll be trying to fetch some of the records from these tables. Select start from where row num is less than 1000. Okay, so you can see there are some operations that is happened in the database. Okay, so randomly it has inserted lots of data, and around thousands of data I have just picked up from my database. So basically what we have done is we have created one table and try to insert 1 million of data, and later we have fetched some record from this table. Okay, now again I will try to fetch this data. Okay, so at this junction we have successfully created a table, inserted some data, and now I will be recreating my snapshot. That means we have two reference point for my AWR reports. Now I will be executing AWR reports. So this is my HTML and number of days 1. So initially this is my first snapshot 29, and this is the second one that we have created. This last two records will be used. Okay, so this will be my AWR report that is getting generated. Is generated. What I will do, I will just download this report and try to show you the results. Okay, give me a minute. So guys, this is my AWR report. Okay, these are the two snapshots that we have referred. Okay, this tutorial is not about learning AWR reports. That should be kept in mind. So our total focus is on wait events. Okay, so you can see in this AWR reports there are various wait events such as a DB CPU, DB file scatter read, DB file parallel read, DB file sequential read, log switch completion, control file, log file sync, direct path read, undo segment extension, flashback log file sequence, and these are the values that is actual waits. This is in wait in seconds, average wait times that is in milliseconds, percentage of total database percentage, and what is the wait class. So it is under user IO again the configuration system IO, commit, log file sync is under the commit wait class, and then we have direct path read under the user IO. So there are various wait events that we can see in the database. Okay, so whenever you are reading your AWR report, you should be focusing on your wait events, but understanding the wait event is very important. So we have chosen a topic called wait events. So coming back to my original documents, we should be knowing what is wait event. So an event that can be defined as a particular function or a task that Oracle kernel performs on behalf of the user's session or its background processes, and that task is reading or writing the data blocks to and from the data files, waiting for a latch acquisition before accessing or manipulating the data in the memory. So if you look at this diagram, this is SG, that is a memory component, and these are my actual data files. So if a user is making a request, so certain operation has to be performed in the memory area, and that is totally depending upon your data file or the buffer cache. If the data is not available in the buffer cache or the share pool, it will go with the data file fetch up, and again it will process those data. And if suppose it is required for a user to get the latch on a particular share pool components, so there are various wait occurs in the database for any operations. So those are tasks and the wait events, whatever is happening in the database is nothing but a wait event. Okay, so event that can be defined as a particular function of the task that Oracle kernel perform on behalf of the user session or its background processes. So it could be a background process related wait events also that should be kept in the mind. So along with the memory component, we have the certain processes such as PMON, SMON, log writer, and we have seen CKPT. So if you want to learn more about these topics, I will suggest you to watch my previous video on Oracle database architecture. So it has a complete information about what are the different processes, what are the different component of any Oracle database. So you will be better understanding those part as well. Okay. So this is my basic understanding of Oracle wait events. But why these wait events? Why these events is called wait events? So that should be next question in our mind. So every session that is connected to the Oracle instance needs a resource to perform its task. Okay, this is my diagram. So every end user who is connecting to the database, requires some resources, and in order to perform its task. Okay, so a resource may be a database buffer, or the latch, the enqueue, that is nothing but a log, or a pin, or a database objects. So it could be anything. Whenever a session has to wait for something, the wait time is tracked and charged to the event that is associated with that wait events. Okay, for example, a session that needs an index block that is not in the SGA makes a read call to the operating system and waits for the delivery of that particular block. Okay, so suppose some user has requested a index block and that is not in the buffer cache. It has to wait for some period of time in order to get that block from the data files. Okay, so that is nothing but a wait events. Okay, the wait time is charged to the DB file sequential read. So in this case, what happens if index block is not available in the buffer cache, it has to fetch it from the data file. That means it is waiting for database block in sequential manner. So DB file sequential wait events is happened in these operations. Another session may be completed the last instruction, and now it is idle and waiting for the user input. Suppose in the next case, what happens, it is waiting for user input. Suppose you have fired some query that requires user input, and user is still waiting, or is sitting idle. In this case, what happens is it will be in idle state. Okay, so in this case, the wait time is charged to as a SQLnet message from the client events. That means it is client level wait events. That is nothing but SQLnet message from the client. In sort of, when a session is not using a CPU, it may be waiting for some resource and action to the complete, or simply more works. So there could be a total 3 scenarios. One is either it is waiting, session is not using the CPU, or it may be waiting for some resource and an action to complete, or simply more work. So there could be a scenario like your CPU is completely busy serving other users. Okay, so that is also possible in the database wait event. Next, events are associated with all such wait is known as wait events. So Oracle wait interfaces has had following 4 views. So using these views, v dollar event underscore name, v dollar session wait, v dollar session underscore wait, and event v dollar system events. So these are the various wait events that we should be looking on database. So what I will do, will describe these wait events, try to get what are the different components. So this is my wait hash, number, wait ID, name. So what we should do, we should select these values from where name, like so you can see this is a select query that I've fired. Let me just check the lines and pages, then we'll try to rerun this query. Okay, so here we can see, and this is my wait event number, wait event ID. This is my wait event name, such as db flash cache write, db flash cache invalidation, db file sequential read, and there are total 3 parameter associated with any wait event, that is called parameter 1, parameter 2, parameter 3. Sometime it is referred as p1, p2, p3. So we'll be discussing more about these things. in later in this tutorial or maybe in upcoming days. So basically wait events, whenever you're looking for any wait events, you should always look for p1, p2, p3 values, so that you should be able to understand what these wait events are associated with. Suppose you have one wait event called db single block read or db sequential read. So there will be a p1, p2, p3 values. Let me just select the specific values from this query. So select name comma p parameter 1 parameter 2 comma parameter 3 from the dollar wait event. Okay. I'm just formatting this so that we can understand it better way. So here we have this query called select name parameter 1 parameter 2 parameter 3 from the dollar event underscore name where name like db. Okay, so you can see there are some wait events such as a db file sequential rate. So it has a parameter value such as parameter 1 as a file hash, block hash, and the block number. So if you are facing any wait events such as db file sequential rate, so you should be getting an idea from by referring these values in the parameters, and that is the file hash value, on which file hash it is waiting for sequential read, and what is my block hash, on which block it is waiting, and the number of blocks that it is waiting. Okay, so in this fashion you will be able to relate your wait events. Okay, so by referring this parameter value is always important whenever you are talking about your wait events in the database. So there are some views are given in the database. So v dollar event underscore name session underscore waits session underscore events system underscore events. So you should be able to get this data by referring these views. If you are using a RAG database, you should use GB dollar. Along with that, you will be getting instance ID also in the GB dollar. GB dollar is basically a global views that you can use for if you are using your real application clustering database. Okay. So as far as this topic is concerned, Oracle wait events, I hope you are able to understand what is exactly a wait event is in the database. So whenever a user is making some request to the database, there could be a scenarios depending upon which your database user has to wait for certain period of time, or your operation is waiting for some period of time. So those scenarios are called wait events in the database. Okay, there are various views through which we can understand the different wait events name and upon which parameter it is waiting. Okay, so next part is introduction to the common wait events. What are the common wait events in the database? So we'll be describing about we will describe what that event means, and what information Oracle uh, provides you in additional with wait parameters p1, p2, p3 in the v dollar session underscore wait view. The extended SQL trace files and the v dollar session view in the Oracle database 10G or later versions. So we'll be also discussing about the wait time or the timeout values for these wait events. So let's look at the first wait event, that is called the buffer busy waits. So buffer busy wait event occurs when the session wants to access a data block in the buffer cache that is currently in use by some other sessions, and the other session is either reading that same blocks into the buffer cache from the data files, or it is modifying one in the buffer cache. Okay, in order to guarantee the read session has coherent image in the block, either all the changes or none of them, the session is modifying the block mark as a block read header, or the flag letting other session to know the change is taking place and wait until the complete happens. Okay, so what I will do, I will show you the practical example. So suppose we have two users. This is my first user, that is end user one, and there is another user, end user two, over here. And this end user is already modifying some blocks from the data file in the buffer cache, which is there in the buffer cache. Okay, so at the same time, there is another user who wants to access the block that is modified by the end user one. Okay, so at this junction, what happens is end user 2 has to wait. Let me just draw the actual diagrams so that you can better understand. So this is my pen, this is my user 2. Okay, this is my user 2 and this is my user 1. So user 1 is already modifying my block. There are some block modification is already going on. Okay, at the same time, this user wants to access the block which is modified by the my first user. Okay, so he will be making, the user 2 is making a request to the database that I want to modify this block. But at this junction, the end user 1 who is modifying these blocks, okay, he will because of his modification, a database will ask the user 2 to wait for a certain period of time. That wait event is called the buffer cache related wait event, because he's trying to modify the blocks which is in the buffer cache, and it is already used by the end user one. So this scenario is related to your buffer cache modification. Okay, let me just clear this out. So I hope you understood what is the buffer cache related wait events. Okay, so moving further, I will be let me just go further. So buffer busy wait event is posted by the session accessing the cache metadata in the database using the automatic storage management. So we can use this, we call with all of wait stats is not component of the Oracle wait interfaces. So using this query select star from with all of wait stats where count is greater than 0. So you can get the statistics of how many data blocks are there and for what time it is. Okay, so next is parameters. So it has three parameters. P1, P1 shows the absolute file number where the data block is question resides. So we have seen various parameters for checking any wait events. So there are total three parameters. So whenever you're talking about buffer cache wait events, so you should be looking at which file number it is getting modified residing, and these blocks are residing the actual block number of the process that it needs, and prior P3 is the number indicating the reason for the wait. Oracle post from the multiple places in the kernel codes. So that is first wait event that we have discussed, buffer busy waits. Okay, so it is waiting for buffer that is held by some other users. Next part is control file parallel write. The control file parallel write wait event occur when the session waits for a completion of write request to all the control files. Okay, So the server process issues these write requests in a parallel mechanisms. So the security process writes the checkpoint position in the online redo log file, redo logs to control file every 3 seconds. So Oracle uses this information during the database recovery operation, also uses to perform the DML operations using either no logging or recovery options. So Oracle records these unrecoverable SCN in the control files. So a recovery manager, that is Arman, records backup and recovery information in the control files. So basically a control file parallel write event occurs when the session waits for the completion of write request to all the control files. So suppose you have a database, okay, so parameter control file. Let me just retry. So you can see control files are located at 2 different locations in my database. So the control file parallel write operation wait event occur whenever the session waits for completion of write request to all of its control files. So in control file parallel wait event will occur when it is waiting to write all the changes on both or the whatever the existing your control files are there. Okay, so this is one of the wait events that is there in the database, and these are the reason codes, or you can say p1 p2 values uh, for what I mean, what could be the scenarios in which your control file parallel write wait events occurs. So you can refer these reason codes such as 100 110 120 and so on. Okay, I'll not go much deeper into those codes as of now. There is no blocking session in the control file parallel write. The session is blocked waiting on the OS side or the IO system completed to write to the all the controls. So there could be a scenarios like there is some storage issue or the IO issue, and your control file write is not happening as per your expectation. So you might be seeing these wait events also. Okay. So P1, P2 values could be a number of control files. P1 value could be a number of control files the server process is writing to, and the P2 value is total number of blocks it is writing to blocks to write to the control file, and the P3 value will be a number of IO requests. Okay, so these are the P1, P2 values, P3 values for your control file parallel write. Next wait event is DB file parallel read. So this is very well-known wait events that is in the database. So basically, control file, uh, control file. Give me a second. So control. So DB file parallel read event is not related to any parallel operation, neither parallel DML nor parallel query. This event occurs during the database recovery operation when the database block that needs to be changed as a part of the recovery are read in the parallel from the database files. So this event also occur when the process reads multiple non-contiguous single block from one or more data files. So I will be going to my original screen. So suppose you have one data block that is distributed across multiple data files. Okay, and one user has made a request to the database that I want this block, which is again distributed to multiple locations on the database. This is what it is saying. The DB file parallel read event is not related to any parallel operation, neither parallel DML nor parallel query. This event occurs during the database recovery operation when the database block that needed changes as a part of a recovery are read in the parallel from data file. This event also occurs when the process reads multiple non-contiguous single block. That means your single block is non-contiguous across multiple data files, one or more data files. Okay, so the weight parameter of a DB file parallels are described here: P1, P2, P3. So number of files to read from, the total number of blocks to read. So it could be like block 1, block 2, block 3, and the last one is the total number of IO request it is making. Okay. Next is DB file parallel, right? So it's contrary to what the name is suggesting. So the DB file parallel write event is not related to any parallel DML operation. This event belongs to a database writer process, as it is the only process that writes the dirty blocks to the data file, and the blocker is either operating system, IO system, and this can also have an impact on IO system. So that is right from the right may impact read times of the session reading from the same disk. Okay, so suppose you are making a request to write some blocks into your data file that is on the same you can say same user file system, such as U01 or U02, or your data file mount point slash data. Okay, so in this case your devices might be busy. Okay, so your data devices might be busy. Because of that, it might be your IO operation might be impacted. So this is what it's saying. A DB file write could be because of the blocker is operating system, IO system. This also have an impact on IO system. In the write may impact and the read time session of the session reading from the same disk. So a database writer compiles a set of dirty blocks into the write batch, and it issues multiple IO requests to write the write batch of the data file. So there are multiple dirty blocks that is required to be written in your data files after some period of time whenever the checkpoint is happening in your database. So these dirty blocks should be written to your data file. Okay, in this scenario, if your IO system is busy, and then this issue happens, like a DB file parallel write events occurs. Okay, so database writer does not wait for the whole batch write to complete, and it waits only for a percentage of the batch complete before pushing a free buffer back into the LRU chance. So it may be issue. It may also issue more write request. Okay, so the P1 P2 values could be a number. P1 is number of files to write to, so it could be a data file 1, data file 2, data file 3. Okay, so it could be a first data file or the second data file. So total number of blocks to write, number of blocks it has to write, and then total number of P3 shows the timeout values for the 70 seconds for to wait for IO to complete. So third one is nothing but your IO time to perform those operations. Okay, next thing will DB file scatter read. Okay, so what is meant by scatter read? So the DB file scatter read event is posted by the session when when it issues an IO request to read multiple data blocks. Okay, the blocks read from the data file are scattered into the buffer cache. So these blocks need not remain contiguous in the buffer cache. So the event typically occurs during the full table scan or the index fast full scan. So if you are reading your entire table as it is in your buffer cache, so there is no need for your database to be in contiguous format like continuous format. So it could be randomly scattered across your buffer cache. Okay, so it could be anywhere in your buffer cache. So that scenario is called the db file scatter read. So using this parameter called db file multi-block read count, your number of blocks that can be read is totally depending upon this parameter. So you might be coming familiar with db file multi-block read count parameter. So it should be related to your reading capacity of your blocks from the data files to your buffer cache. Okay, so waiting on a data file IO completion is normally uh, in any Oracle database. The presence of this wait event does not necessarily indicate the performance problem. However, the time spent waiting for multi-block read is significant compared to other wait events. Okay, so what are the total p1, p2, p3 values, that is parameter for this wait event db file scatter read? So first one is the file number to read the block from, starting block number and the beginning begin reading, and third one is number of blocks to read. So the wait time is this one. So no wait time, the session wait until all IOs are completed to read a specific number of blocks. And next one is db file sequential read. In the db file sequential read, wait events occurs when the process waits for an IO completion for a sequential read. The name is a bit misleading, suggesting a multi-block operation, but this is a single block read operation. The event get posted when reading from for an index rollback or the undo segment table accessed by the row ID. That means you are accessing a single block from your data files to your to your buffer caches. Rebuilding a control file, dumping a data file header or the data file header. The waiting for data file IO completion is normally an Oracle database. The presence of these wait event does not necessarily indicate the performance problem. However, if the time spent waiting for a single block read is significant compared to the other wait events, that then this should be a problem that should be investigated. Okay, so DB file sequential read is nothing but you're reading a single block from your data file to your database buffer cache. Again, the P1, P2, P3 values is nothing but file number from where it is reading the block. P2 is starting block number to read. P3 is the most, but the temporary segment that can be more than one. Okay, this is one thing. The next part is db file single write. So db file single write event is posted by the database writer. It occurs when Oracle updating data file header, typically during the checkpoints. So you may be notice this event. So if you want to learn more about the checkpoints and all those stuff, so you should be visiting my previous videos on Oracle database architectures, where I have um, I have um, discussed entire details about different processes and the different components of your Oracle database architectures. Okay, I think you should watch those videos also. And in upcoming days, I will be covering lots of performance tuning related stuffs, and that will be a totally practical sessions, including, different areas of performance tuning. So, if you are new to my YouTube channels, I will be requesting again to subscribe so that you keep on getting all these stuffs without any anything. Okay, so let's move further. We are discussing DB files single read. So this event is posted by the database writer. So it occurs when Oracle is updating your data file header and typically during the checkpoints. Okay, and you may notice, so whenever your checkpoint is happening, so database writer will update your data file header. So it will write the current checkpoint information into your data file header. Okay, so during this point, you may notice that this event when your database has ordinate number of data files. Okay, so again the p1 p2 values are there. P1 is file number to write to, starting block number, and the number of blocks to write. So this is the one thing that we have discussed. Next part is direct path read. So direct path read is nothing but direct path read event occur when the Oracle is reading a data block directly into sessions PGA instead of a buffer cache into the SCA. That means, let me just go to our original architectural diagram. So this is my PG area in the database instance. So this is my SCA, this is my PGA, and these are the background processes. These are my server processes. This is my client application. So if my user has requested some data that is accessed via a PGA memory components from my database files. These are my database files. From here, it is accessing the data using my PGA programmable global area, not through the SGA. That is my actual shared memory components. Okay, so if that is the scenario, then PGA instead of buffer cache in the SGA. So direct read may be performed in synchronous IO or asynchronous IO mode, depending upon the hardware platform or the value of initialization parameter. That parameter is disk async IO or the direct read IO, is normally used while accessing the temporary segments. Okay, so if you are performing some temporary segments operations that is residing on disk, then you might be using your PGA components for this operation. And that at that time you might see the direct path read events in your database. And those are like what are those events. So either you are performing some sorting operation or parallel query, or you're using a hash join. So in those scenarios, you will see the direct path read events. Okay, so the number of wait and the time wait for these events are somewhat misleading. If the asynchronous IO is not available, the session wait till the IO completes, and but these are not counted as a wait at the time of IO request is issued. The session posts a direct path read wait events when accessing the data after the completion of IO request. So in this case, the wait time will be negligibly very small, and if asynchronous IO is available and is in use, and then session may be issued a multiple direct path read request and continue to process the block that is already cached in the PGA. So the session will register the direct path read wait events only when it cannot continue processing because of the required block that has been that has not been read into the buffer. Therefore, the number of read requests may not be same as the number of wait events. Due to this anomalies, it is unlikely that you will be see these wait events reported in the $V system event or $V session wait events. So what are the parameters that is associated with this wait events? First one is P1, that is absolute file number to read from the starting block, and P3 is nothing but number of block that is getting read. Okay, and similarly we have a direct path write. So the direct path write wait event is just an opposite of operation that is a direct path read, and in this case Oracle writes buffer from the session PGA to the data file. A session can be issued a multiple write request, and the continue processing. So you can see this is my programming global area. User has requested some operation. So from here, PGA, it is writing directly to your data file. It is not going into your SGA for the operation to perform. And that scenario will call it a direct path write. Okay, so direct path write operation is normally used when writing to temporary segments. So either you are performing insert with append hint or a parallel DML operation. So those scenarios are covered in this wait events. Next one is Enqueue. So what is Enqueue? Enqueue is nothing but a shared memory structure used by the Oracle to serialize the access to the database resources. So as we are totally familiar that whatever the operation happens in the memory that is used with the help of system global area or shared memory area, that is also called the SGA. Okay, so there has to be a mechanism through which all the users requests are served. Okay, so there is something called Enqueue. Enqueue is nothing but a shared memory structure used by Oracle to serialize the access to the database resources. So all the database resources such as memory or the processes are served with the help of Enqueue. Okay, the process must be acquired and the Enqueue lock on the resources to access it. So whatever the resources are there in the memory area, and that should be given to all the user request with the help of Enqueues, that is a locking mechanism to provide a serial access to the database resources. Okay, the process will be waiting for this event if the request to acquire the Enqueue is not successful because some other session is holding the lock in the resources. Is incompatible mode, and the process wait is queue for the return to acquire the requested Enqueue. That means suppose there are multiple users such as user 1, user 2. So if they are making a request to the system global area and the one user is already using Enqueue, let me just draw the diagram, then you might be getting better. So suppose we have Enqueue over here. Okay. End user 2, end user 3. So my first user has already using this Enqueue that is used to perform the shared operation for the resources such as SGS, shared pool, component, buffer cache. So again, the second user comes and he wants the lock on the Enqueue shared memory component, and third user comes who also wants to have a locking on the shared objects. Okay, so what happens if the second user or the third user who is not getting these locks or the Enqueue, then these wait events will pop up in your database. Okay, so the process wait in the queue for the return to acquire the requested Enqueue. A simple example for such Enqueue session waiting for an update or row when the some other session has updated row and not yet committed or rollback, and this is the transaction that has a lock on its exclusive modes. Okay, so basically there are different locking mechanisms. So there are various types of Enqueue serialized access to various resources, and one is called ST, one other is called SQ, third one is called TX. So ST is nothing but Enqueue for a space management transaction. SQ is nothing but Enqueue for a sequence number. So again, these are the different wait events that can be occurred. And Enqueue TX, that is Enqueue for transactions. So if you are seeing Enqueue or TX contention, that means this wait event is happening in your database. That means a transaction that is already initiated by some users and it is not yet finished. Either it is waiting for commit or some other operation to finished, and meanwhile some other user is trying to access the same enqueue on that objects to perform this transaction. So that is called the enqueue TX contention. If there is some sequence related events are happening in the database, if user is not able to get a particular sequence, and that means it is a enqueue SQ, that means enqueue sequential wait events. And if it is a enqueue ST, that means it is waiting for some space management transaction operations. Okay, I hope you are able to understand what exactly the enqueue is all about. If you're understanding these topics, please click on the like button so that I will be a little happier. And next part is so basically there are P1, P2, P3 value associated with enqueue wait events. So P1 enqueue name and the mode requested by the wait events, and this information is encoded in an ASCII format. So the following SQL statement shows how you can find out the enqueue name and the mode requested by the waiting process. So using this query called select SID, then we have this formula to identify the SID and the name and the mode in which it is held, the enqueue is held. Okay, then P2 is the resource identifier that is requested log. Using the log.id, you can get P2 values, and again similarly you can get the resource identifier that is ID requested log, who has requested the log. Okay, so the wait time depend on the enqueue name, but it is the case of Oracle wait for up to 3 seconds or until the enqueue resource become available, which occurs first. Okay, whichever occurs first. When the wait event timeouts, the Oracle will checks that the session holding the log is still alive, and if so, wait again. So this is a cyclic, it is a event that keeps on occurring. So it will be waiting for some period of time, then again it will wait for some period of time. So this cycle keeps on going. So next one is free buffer waits. So free buffer wait event occur when the session cannot find the free buffers in the database buffer cache to read the data block. Okay, so this is my, if your database buffer is already exhausted and no user is able to get any free buffer, then this wait events will occur. That is called the free buffer waits. Okay, so the database writer will write some dirty buffer from the buffer cache to your data file. So some using the DB writer. So let me just clear this out. So using the DB writer process, this dirty buffer will be written in your data file blocks. Okay, so these are the file numbers from which it is from which Oracle is reading the block, and other information can get from this. Next part is latch free. What is latch free? So the latch free wait occurs when the process waits to acquire the latch that is currently held by other process. So like Enqueue, Oracle uses a latch to protect the data structure. Now we are talking about data structure. Okay, so the one process at a time can either modify or inspect the data structure after acquiring the latch. Okay, so the other processes needing the access to the data structure must wait till they acquire the latch. That means you are modifying the data structure and you want some lock. Okay, so unlike the enqueue processes, requesting latch do not have to wait in a queue. So in our previous case, that is in enqueue, we do not have to wait over here. So latching is a little different in working mechanism. If the request to acquire the latch fails, the process simply wait for a short period of time and request the latch again. The short wait event is called the spin. If the latch is not acquired after one or more spin iteration, the process sleeps for a certain period of time and acquires the latch again, sleeping for a successive and longer period until the latch is obtained. The most common latch you need to know about is cache buffer chain or the library cache shared pool. These These and the other latches are discussed later and other chapters will see later. So weight parameter related to these latch free wait events are such as P1 value is something where address of the latch for which the process is waiting, and the P2 is the number of the latch. So there are various number of latches and latch name details. So using the $v latch name dot latch hash, we can get this value for parameter 2. To find out the name of the latch, you can use the following SQL statements such as select star from $v latch name where latch hash equal to P2 value, which will get during our video. Like we can monitor these values from $v session also. We can get the P1, P2, P3 values. Okay, so last one is P3. The number of tries or the counter shows the number of attempted processes to make acquire on the latch. Okay, so the wait time for which this event increases exponentially, it does not include the time for the processing spending on the latch. Okay, this is one thing. Next topic is library catch-up pin. So library catch-up in wait events is associated with library catch-up concurrency. It occurs when the session tries to pin an object in the library cache to modify or examine it. The session must acquire the pin. So whatever we discussed previously in latch options, so we are discussing much deeper into that. That is called the library cache pin. So library cache pin occurs cache concurrency. So it occurs when the session tries to pin an object in the library cache to modify or examine it. The session must acquire a pin to make sure that the object is not updated by the other session at the same time. Oracle posts this event when the session compiling or parsing the PL SQL procedure or the views. Some of these latch events are such as latch in memory undo latch, latch cache buffer handles, latch cache buffer chance, latch cache buffer LRU, checkpoint queue, redo copy, redo writing. So there are latch shared pool, latch undo, global data. Okay. So next thing, what action to take to reduce these wait events? So common problem scenarios is use a dynamic SQL from the within a PLSQL procedure where PLSQL core recompile and dynamic SQL calls something that depends on the calling procedure. If there is a general widespread waiting, the shared pool may need a tuning, and if this is a blocking scenario, then following SQL can be used to check for what is the what session is holding and requesting the pin object that is given by the P1 in the wait events. So we can identify the session who is holding these logs, and then we can clear them out and those things. Okay. So far so good. Wait time for the PMON process is 1 second, and for other processes is 3 seconds. Next one is library cache lock. So library cache lock event is also associated with the library cache occurrence concurrency. A session must be acquiring a library cache lock on object handle to prevent the other session from accessing at the same time or maintain the dependency on the long time or to locate an object in the library cache. Okay, so library cache wait events is associated with the library cache concurrency, and the session must be acquiring a library cache lock on object handle to prevent the other session from accessing it at the same time or to maintain the dependency for a long time and to locate an object in the library cache. So these are the P1, P2 values. P1 addresses the object being examined or loaded, and then P2 is address of the load log, and P3 is contains the node of plus the namespace. So using $DB underscore object cache view, we can identify the object namespace. Okay. So for PMON process, it is 1 second, and for other, it is 3 seconds of time that library cache lock can be occurred. So next one is a log buffer space. Again, now we are moving to some other components. So log buffer space wait, it happens when the session has to wait for a space to become available in the log buffer to write the new information. So if you go to this diagram, here we have the log buffer. If there is a no adequate space available in the log buffer, a read log buffer, then in that scenario it has to, your request has to wait for a log buffer space, and the LGWR process that is responsible for cleaning out the read log buffer from buffer cache to your read log file. So it will clear out the data from your read log buffer, and it will write to read log files, and then this process can continue. Okay, so if there is IO contention, these wait events can be more, or this is negligible. Okay, next one is a log file parallel write. Log file parallel write wait occur when the session waits for the LGWR process to write the redo from the log buffer to all the log members of the redo logs groups, and this event is typically posted by the LGWR process. Okay, so that means your redo log buffer is already requested to write some process using the LGWR into your not data file. I will cut the data file over here. I will write redo log file. Okay, redo log file. So this is my redo log file, and LGWR wants to write the redo log buffer, and if it is not able to write within some period of time, because of some reason, either your LGWR process stuck somewhere or there is a slowness on your IO system, then this scenario may result into the log file parallel write wait events. So the LGWR process write to active log file members parallelly in if asynchronous IO is in use. Otherwise, it write to each active log members sequentially. The weights on the these events usually indicate slow disk devices or the contention where the redo logs are located. So in there might be scenario like your IO storage is slow, on which your redo log files are getting written. So that could be and result into your log file parallel writes wait events. So there are these are the three parameters. P1 is nothing but a number of log files to write to. P2 is number of OS blocks to write to. P3 is number of IOS requests. Okay. So actually the elapsed times take to complete all the IOs, and although the log files are written in parallel mode, the write is not complete till the last IO operation is completed. Then this is the scenario of wait events. So next one is the log file sequential read. So log file sequential read wait occurs when the process wait for blocks to read from online read log files. The archiver process encounters these wait events while reading the redo log files, and this parameters could be a relative sequence number of the redo logs and redo log groups and the block numbers to start reading. So log file sequence will happen in case of you have the archive process, ARC process. Okay, and you want your due to some reason your database wants to read some archive or the redo logs. Okay, and if it is waiting due to some reason, and it is I mean due to some process slowness, it is reading the online redo log file. The archive process encounter while reading the redo log. So this could be a IO intensive operation. If your IO is slow and it is not able to read within a certain period of time, then log file sequential read wait event will happen. Again, there are three parameters. One will be your sequence number of your redo log. So that is nothing but your archive sequence number, then block number to start the reading from, the number of OS blocks reading from. Okay, this is one thing. Next part is your log file switch or archiving needed. So this wait event, when this occurs, so log file switch wait indicates that the archive process is not keeping up the LGWR process writing to redo log files. When operating in the database is archive log mode, the LGWR process cannot override or switch to the redo log file until the archiver process has archived its copy. Okay, and to its destination. A failed write to archive log destination may stop archiving the process. Such an error will be reported in the alert log also. So suppose your archiver process is slow in writing the redo log file that is supposed to be archived into your archive log destination. So this scenario may result into archive log switch wait events, or due to some like suppose your destination is already full due to some reason, and there is no sufficient space left in your um, archive destination. So this may result into your log file switch wait events, or if your IO is a little slower and your archive process is not able to write the redo log files in your archive logs, so there will be a log file switch wait events in your database. Okay, next is there are three different scenarios, such as first one is archiving needed. So if you are saying the archiving needed, that means there is some requirement, there is a request to raise an alarm is made that your database required to write the redo log files from redo log files to your archive destination. Okay, next one is log file switch, that is for checkpoint incomplete. So the log file switch wait indicates that a process is waiting for the log file switch to complete, but the log file switch is not possible because checkpoint process, that is that log file has not completed. And you may see these events in the redo log files are size too small. So whenever your redo log file size is very small, so you might see the checkpoint incomplete wait events. Why we are seeing the checkpoint incomplete? Because the process is waiting for redo log switch to complete, but the log file switch is not completed because the checkpoint process for that log file is not complete. So wait parameters are not used for log file switch checkpoints, and the wait time is 1 second. Next one is a log file switch completion. This wait event occur when the process is waiting for a log file switch to complete, and again this is 1 second wait event. So last one, log file sync, when the user session completes the transaction, either a commit or the rollback or the session redo information must be written into the redo logs by the LGWR process before the session can continue processing. And the process waiting for the session event while LGWR process complete the IO operation to the redo log file. So if the session continues to wait for the same buffer has sequence has column, wait events should be incremented every second. So next, if it is, if not, then the local session has the problem with the wait event timeouts. If the sequence has a column is incremented, the block processes LGWR process and check to see what LGWR process is waiting on, because it may stack. So tuning the LGWR process to get good throughput to the disk. For example, do not put a redo into RAID 5 disk array, or if there are a lot of short duration transaction, see if it is possible to batch the transaction together so that fewer distinct commit operations done. Each commit has to be confirmed that the relevant redo is written to the disk. So although the commits can be piggybacked by the Oracle, reducing the overall number of commits by the matching the transaction can have a very beneficial effects. Okay, So if you are seeing the log file sync wait event, you should also look at the number of commits that is happening in your database. If it is too frequent, you should try to make it in batch process. Okay. So P1 value is the number of buffer in the log buffer that is needed for to be synchronized. Next wait event is SQLite message from the client. This wait event is posted by the session when it is waiting for a message from the session to arrive. Okay, that means generally this means that the session is sitting idle and excessive wait time on this wait event in the batch program that do not interact with the end user at the keyboard may indicate some efficiency in the application code or in the network level. However, the database performance is not degraded by the high wait times for the wait events, because this event clearly indicates that perceived the database problem is actually not a database problem. So if you're seeing the SQLite message from the client, that means it is a wait at the client and not at the database end. Okay. Again, you can refer this P1, P2 values, and you can relate your problem SQLite message to the client. That means this wait event is posted by the session when when it is sending a message to the client. The client process may be too busy to accept the delivery to the message, causing the server session to wait on the network latency delay, or delivery might be taking some longer period of time. So again, we have these P1, P2, P3 values, and wait time, the actual elapsed time it takes to complete the message delivery to the client. Okay, so with this, I hope you are able to understand what is Oracle wait events and why it is important to understand every wait events. There are there are various wait events in the database. I will be suggesting you to go to Oracle database website, so where you will be getting lots of details about different wait events. There are so many wait events, but I try to cover some of the generic or Oracle database events. So there are other wait events like such as uh, GC wait events if you are working on a rack environment, or local cache wait events, or if you're working on some exa database. So those wait events are also there. So I will be covering maybe in upcoming videos some of the top wait events apart from these wait events. And I will be requesting you to watch my previous video on Oracle database architecture to understand or different components of Oracle database architecture. If you haven't watched those videos, you just go through the video. Also, I will be requesting you to watch other videos such as how to configure RAG database, and how to perform some data guard operations such as switchover, switchback, and how to create physical standby database. Okay, so I hope you are able to understand different wait events in your database, and we have taken one demo. And so if you see these wait events in your database, so DB is nothing but your database is working as per your utilizing your database CPUs. So this should be your always a top wait events, and that means your database is busy and it is working fine. And there will be some other wait events such as highlighted over here, and there are various wait classes for each wait events. Okay, so maybe in upcoming days we'll be learning more about different wait classes and related to wait events. So for time being, I will be stopping here, but before going for stopping this video, I will be requesting you to subscribe my YouTube channel or Oracle DBA Online Training, so that you keep on getting all these updates. Once again, guys, thank you for watching this video. Have a great day. Bye bye.